Hey guys, how's it going? Today we're going to be using an oscilloscope to test a function generator. We'll power on, and we've got our frequency here. So now we're currently on a square wave. You guys can see that here. This is the coarse frequency. It goes from like 10 hertz to 100,000 hertz. So we're currently on 10 hertz there. These two knobs are actually resistant, so they're potentiometers that you can adjust resistance with. So these ones are not included with the function generator. This is the function generator here, all of these knobs here. And the fine adjust is all the way down. That's definitely not 10 cycles a second. I mean, that might be 10 cycles a second, right there with the fine adjust all the way up. I'm gonna set the amplitude and the DC offset. I'm just gonna set them to the middle position. Looking at this, you can't really tell, just looking at this light, you can tell sort of the frequency, but this doesn't tell you like what type of wave it is. Is it a square wave? Is it a sine wave? Is it a triangle wave? There's no way to tell. Let's take a look at this signal first with a multimeter and we'll see what we get. So obviously this is gonna be a alternating current signal. So we'll take this. So this is our ground pin. We'll connect this to ground. So the multimeter is just showing that we're getting 10 volts, but we don't know what kind of wave this is, what frequency that alternating current is going at. We don't really have any information, we just know 10 volts. So that's what a multimeter can do. Now let's take a look at the oscilloscope. Okay, so with the oscilloscope, we're going to connect. This guy needs to go to ground. We've got a grounding wire here. Okay, so this is going to be our frequency output. We'll connect our oscilloscope here. So I'm just going to hit the auto button. And we're pretty zoomed in. Let's do it one more time. Look at that. There's our signal. We're really zoomed out right now. So we'll zoom in a bit more. I think, okay. This is our kind of zoom, or vertical zoom. So as you guys can see, as I turn the knob, we're zooming in closer and closer to the our signal. This knob is the horizontal. And as you can see, you can zoom out horizontally. This one's kind of changing the time that we're looking at the signal. So we're zooming in the time and the time axis, I guess, and you can see that as I zoom in, make the time shorter, it's going faster and faster until we get to this point, which actually hit the trigger. So it'll freeze the signal in place. So we can kind of take a look at it, and we can zoom in and zoom out vertically on the signal. What's interesting is this is telling us we're getting positive 1 volt to negative 1 volt. So I don't know why we were getting 10 volts on the multimeter. Our time is divided by 20 millisecond blocks. So each of these blocks is 20 milliseconds. So we can see how long it takes for one cycle of the wave. So we're getting way more information with this than we did with the multimeter. So from what I know so far, the oscilloscope has 3 important sections. I mean, there's more to oscilloscopes obviously, but this is sort of the beginner understanding that I've collected so far, which isn't much. So you've got the vertical adjustment, the horizontal adjustment, and then you have your trigger. And the trigger, you guys can see it down here on the bottom. It's just, what you need to do with the trigger is bring it onto the wave, and it will pause the wave. See how that kind of worked? If you press the auto button, it'll zoom in where it needs to be, it'll set the trigger, and then you'll just see the wave. But the wave is not actually frozen. Obviously, the electricity is like constantly moving. So that's the third section of the oscilloscope, is this trigger. And this is important because if it's not on the wave, your wave can be moving like that really quickly. You can't really see what's going on sometimes. And so what we do is we just zoom in and zoom out. We can just bring that trigger right to where we need it, and it'll freeze the wave in place. So that's my very sort of basic understanding of the oscilloscope so far. And yeah, it's pretty cool. Okay, so we have that now. Let's check out the fine adjust and see what we get exactly with this. Well, actually, let's try the amplitude. Nothing from the, oh, whoa, Okay, yeah, we are getting something from the amplitude. That's pretty cool. It is changing sort of the voltage. And when we max it out, yeah, we just get 1 volt peak to peak. That's what's cool. See, so the oscilloscope is showing me in real time, so I can really see what the function generator is doing. So now I know that this knob doesn't actually do much once it's past halfway. The wave isn't moving. Then I get to about halfway and start going down, and now it's starting to affect the amplitude. And now it's moving here because it's going outside of my trigger. So that's the amplitude. The DC offset, what does this do? Well, doesn't seem to do much. I'm not sure what that's doing exactly. Okay, and then the fine adjust. Fine adjust allows us to, we can zoom out. This is the fine adjust. Oh, look at that. So the wave period is getting a lot longer with the fine adjust. As you can see with the LED as well, LED here is also it's going pretty slow. And as we speed it up, you can see the wave is moving faster. And we go all the way to the maximum. And you can see the LED flashing really quickly. I'm not sure what you'll see on your screen because our camera is at a different frame rate. So it's not going to show the LED properly, probably. That's super cool. Look at that. And I just slow it down. And there's our wave, our square wave. Let's go to a triangle wave. About the DC offset. Oh wow, okay. That's interesting. All right. Let's try the sine wave. All right, so those are our waveforms. It seems like everything kind of has a square bottom to the waveforms. So it's not the sort of sine wave I was expecting to see. I'm not sure if there's other ways to adjust it. Okay, so I wanted to do a bit of an update. I solved the problems that I was having. So I was getting 10 volts on the multimeter and I was getting 1 volt peak to peak on the oscilloscope. And I wasn't sure what was going on there, and I figured that out. And then I also figured out why the waveforms were like flattened on the top and bottom, and I'll tell you about that in a second. So I solved the voltage problem by flipping the switch on the probe. So there's a by 1 and by 10. The by 10 actually divides by 10, and that's what we were at. So we're still getting, as you can see there, 1 volt peak to peak, but if I flip the switch, we'll get, now we're at 10 volts peak to peak. So perfect. So we got that figured out. And then also the clipping. So you guys can see here, I'll switch over to, there's my triangle wave and my sine wave. And the problems I was having was the amplitude was too high. So you guys can see it clipping there on the top and bottom. And then also the DC offset. This has to be in the middle position. Otherwise, you see the waveform will go too far down, or you can kind of shift it too far up. So that's what was causing my flat bottoms on the waveform. So there you go. I'm happy that I kind of figured that out. And yeah, if you guys have those problems at all, then you know why. I know that's some beginner stuff, but I am a beginner and I'm still learning. And yeah, it was cool to learn that firsthand. So yeah, I think that was a pretty cool little test. So I guess in a nutshell, that's kind of what oscilloscopes are for. You can really get so much more information about like an electrical pulse or electrical signal than you can from just your average multimeter. I hope that shines some light on why we might use an oscilloscope over a multimeter. And yeah, I hope you guys are doing well out there. I'll upload some more videos pretty soon. See you guys later. Thanks for watching. Please subscribe and check out one of these other videos.